Alright, so this is the day 18 learning hints. So for the learning application today, we have to complete the worksheet provided, which is going to be that worksheet. Then we have to do day 1 problem 1 following the instructions. And then we do not day 1 problem 1, then day 18 problem 2, which is this guy. So let's take a look. Let's start from the top here. So list all the dimensions, including plus minus for A, B, C, D, required to make the following fits. Alright, so for this assignment, we're going to need our fits sheet, which is going to look like this. Right? This tells us the fits that we have, so we're going to run through how to use that in a second. And then we're probably going to need these parts. So what I would do is I would go to McMaster-Carr. What we can do there, I've already downloaded them, so I'm not going to download them again. But basically, you're going to type in this number. So we're going to do 31445A116. And when you type in that number, see, found that. So we can go to product details. And then, this looks a lot like that, right? Because it's, it's the same thing. We now are there. And from here, you can go to 3D SolidWorks, which is automatically selected, and you can save this. And what that does is that it's going to save. I just downloaded it, and so it's going to save that part. And then you can open that part in SolidWorks. It's a SolidWorks file. I'm just going to change the background real quick so we can see it. But that is the part. And this is what you need because you want to download it because otherwise this assignment is going to be extremely challenging. So now that we have this, we'll just make a drawing from this part. You'll do this for the other one as well. And it's a English part, so I want my English template. I'll take that one actually. Okay. And then I will bring over, the front view. We only need that middle hole, right? Okay. Just bring over that guy for fun. All right, so this is that part here. And from here, let's take a look. So let's split this in half real quick. Let me split you in half. There we go. That's the learning. Okay. So for this one, right, it's the inside, this whole dimension right here that we're trying to get. And so if I go to this, I'm in ISO. Why am I in ISO? Fix that real quick. Tycho Power C. It says I'm in ANSI. My computer's dumb. I'm really in ISO. Okay. So now that we have that, let's take a look. Okay. So we're doing a whole basis. A loose running fit for wide commercial tolerances or allowances on external members. All right, so if we go to our fit sheet, let's find the whole basis for a loose running fit. So we're doing whole basis, so any of these, and then if we go over, it's the first one, loose running fit for wide commercial tolerances or allowances on external members. We're making it easy for you. So basically what we're doing is we're taking a look at this, and we're seeing, okay, so I know that for A, let me also open up, actually, before we really get started here, let me also open up this one so we can do it both at the same time. I'm going to File, Make Drawing, Browse, My Downloads, English. Okay. I don't think it's smart to mention yet because I need to bring this guy over. So I'm just going to bring this over. It's going to be very small, and so what we can do is we can actually just click on him and change the scale. So let's go like 4:1 or something. Yeah, that's big enough. All right, so now we have this, and now we can take a look at both these real quick. So we have this model and this. Okay. So for A, right? So let's do A. We'll do A. We'll do these four as an example, and I'll try and have you do the other ones as an example, on your own, I mean. So whole basis, loose running fit for wide commercial tolerances. We found that, right? That's right up here. We know the whole basis, so it's going to be H11, C11, because shaft basis would be C11, H11. And pay attention to the capital and lowercase. So A and B, for A and B, that's going to be the capital letter out of that. And the lowercase letter is going to be for the shaft. So when we go to here, if we're taking this guy, I know that that needs to be at H11. So we're going to add a tolerance with fit. And I'm going to make this a little more exact. And I know that we want a H11 fit for our whole basis here. H11. Okay. Now you can see it's 0.0035 and then 0, right? Because you only want this hole to be bigger than it needs to be, right? Because this is a loose fit, right? This hole should be bigger than the shaft that goes through it. So you don't want it to be any smaller than 0.25, but you do allow it to be bigger. And so over here, because we're asking you for the list of dimensions, we're not just asking for you to write H11, C11, okay? And so can I edit this text easily? I think I can. Yeah, edit text. There we go. All right, so let's actually bring that right here. Okay, so if I'm editing this text, since we know A and B are the H11 aspect, I know that we're going to be plus. Oh, I don't know why that just got screwed up. This may give me problems because this PDF is not great. There we go. Just do that. Okay. So this is going to be plus 0.0035, and then minus 0. Right? So we'll go point. Then you want to have the same amount of specificity. You want to specify the same amount for both of these. And then we're going to have C11 for shaft, right? Let's go to, whoops, let's go to this and that. So if we're adding a dimension here, again, my computer is for some reason defaulting to ISO. And the reason I know it's defaulting ISO is because this goes sideways. You'll see as we change that here. See, how it goes sideways. All right, and we're going to add a tolerance to this as well. I'm going to bring that up a little. We're going to do fit with tolerance, and I know that this needs to be lowercase c11. So, right, because we're going h11, c11. Yep. So we're going to go c11. Okay. And we're going to have, so we're going to have 0.003 for our negative. 0. And then negative 0.0065. I added another point. All right, and what you can note here for taking a look at this. So this is a loose running fit, which means that the shaft is going to be smaller than the hole, right? There should be no interference between the outside wall and the shaft that's hitting it. And that makes a lot of sense when we see this because we're allowing the hole to be a little bit too big, right? But no smaller than the 1/4 of an inch that it is. And for the shaft, we're only allowing the shaft to be too small, right? For this fit, it's a 1/4 inch, but it can only be smaller than a 1/4 of an inch by 0.003 and 0.0065. So that should make sense. It's supposed to be a super loose fit, so this is going to be too small, and this is going to be too big. Obviously not by very much, right? We're talking hundreds and thousands of an inch. But that's what you should get for that. So this is how you kind of run this. So try these on your own. When you do shaft bases up here, right, we're going to, instead of using the whole basis, these left numbers, we're going to use the numbers on the right. We're going to use the shaft basis. But that's how you get them to work in SolidWorks. You don't add both of them in here because if you add both of them, then SolidWorks gets all mad and it's not going to display what you want. Yeah, that's how you do that in SolidWorks. Let's take a look at problem 2. So problem 2, we're asking you to get out of next here? We're asking you to create SolidWorks parts of these. So they don't need to be, right? We're obviously not giving you any size on here. We're giving you the bushing size. So the outer diameter of the bushing is 0.75, and then the inner diameter is 0.5 inches. And then dimension the parts so that there's a clearance fit between the shaft and the bushing, and an interference fit between the bushing and the mount. So there's going to be a clearance fit between these two, right? So there's going to be a clearance fit there, and then there's going to be an interference fit between the bushing and the mount. Okay, and what you need to know is that the bushing is the part that is precision. So what that means is that when you're putting this bushing into the mount, you're going to be using a shaft basis, right? Because this shaft is the thing that we know. But the opposite for in here, right? Because there's a hole here. For measuring the fit on this, you're going to have a hole basis, right? Because the hole is the thing that is precision that we know. So that's a little hint for that. And then we have this right here, and this is then just a section view that's a little offset here. And the material is cast iron, so you're gonna hatch it how you usually would. But this is just another one of those examples. So what we're looking for you to submit is you can either do what I did and type out, if you have a PDF editor, you can type out what the answers are up there. And then if you have or if you just print it out, you can then write it down. It doesn't matter. But we're looking for, the dimensions on each one. If you want to write in that, this is going to be H11 and this is C11, be my guest. You should just submit that. Then for these, we're looking for you to submit, so follow the instructions, upload a zip file of all of these parts zipped together. All the parts and all the drawings, and then a PDF of the drawing. So we're asking to see, the reason we want to see a PDF is we don't need you to fully dimension these, right? All we're looking for is the fits, right? That's what we're testing today. So show us the fits that you have on those, knowing, what it is here. So there's going to be a few right answers because there are a bunch of, like if we're asking for an interference fit, there's a bunch of interference fits, right? There's 3 right here. So we're asking for one of those 3 on there. So upload PDFs of the fits, and then for this, just scan it, do it on an iPad, do it on paper. Doesn't matter. You can use rulers, so it doesn't really matter for that. But just upload a PDF of that. So you should have a few PDFs in this homework or in this learning. But that's it for the learning. So we'll come back and we'll take a look at the application.